Welcome to This Explainer. Today, we're diving into a concept that literally sounds like it was pulled straight out of a science fiction movie, and that is antimatter propulsion. Is it the ultimate key to unlocking the cosmos? Or is it just an impossible dream? Well, let's dive right in and find out. Elon Musk recently threw out this massive claim. The future of space travel is antimatter. Now, that is a profoundly huge expectation to set. It completely bypasses the chemical rockets we're watching launch today and points toward a fundamental, mind-bending shift in how we move through space. But the real question is, can the physics actually back this up? Revolution or science fiction? That really is the core mystery we're trying to unravel here. Are we standing on the brink of an incredible propulsion revolution that's going to open up the deep solar system? Or is all this just visionary hype? To answer that, we have to look at exactly where we stand today. Looking at the current state of space travel, we are genuinely living in a golden age of spaceflight right now. Heavy lift rockets are practically a normal, everyday occurrence. But there's this invisible bottleneck that engineers are fighting against every single day. Think about the incredible multi-planetary vision of SpaceX's Starship or NASA's huge Artemis lunar ambitions. They're amazing, right? But despite all that ambition, chemical rockets hit a hard physical limit. They're fantastic for getting us to the moon, but the second we look toward the deep solar system, the so-called tyranny of the rocket equation kicks in. Basically, you end up needing more fuel just to push the incredibly heavy fuel you were already carrying. It's a frustrating loop. The contrast here is just staggering. Today's chemical propulsion requires these towering, massive silos of highly flammable liquid just to inch payloads into orbit. Antimatter, on the other hand, it promises literally microscopic fuel requirements. We're talking about fractions of a single gram yielding unimaginable, immense theoretical speeds. But how exactly does a microscopic speck generate that much power? The secret is a process called annihilation. When antimatter and regular matter collide, they don't just burn like normal fuel. They perfectly and entirely destroy each other. It's a 100% complete conversion into pure energy with absolutely zero waste. It is literally the absolute maximum efficiency allowed by the laws of physics in our universe. And this is exactly where Einstein's famous E=mc² comes into play. Because the speed of light squared is such a colossally massive number, completely converting even a tiny, microscopic speck of mass through annihilation produces just a staggering, almost incomprehensible amount of power. It really is the mathematical holy grail of propulsion. If we map this out like an evolutionary ladder of propulsion, the path is super clear. We start down at step 1 with our chemical rockets, push up to step 2 with nuclear for better efficiency, harness the power of the stars at step 3 with fusion, and sitting way up there at the very top, step 4 is antimatter. Every single step up that ladder slashes the fuel you need while exponentially boosting your speed. If we can actually reach that top step and build these engines, the entire paradigm of human existence shifts. Antimatter spacecraft would drastically slash travel times to the outer planets. Just imagine this for a second. Orbital refueling stations scattered between planets, active asteroid mining operations harvesting rare materials, and a fully connected solar system economy where transit takes weeks instead of years. It takes us from being just a planetary species to a true solar system civilization. The engineering reality. Okay, before we all pack our bags for the outer planets, we really need a reality check. The fundamental science of annihilation is entirely proven, but the real-world engineering required to actually harness it, that is arguably the hardest task in human history. We are currently facing 3 absolute monster roadblocks here. First is production. Right now, we can only create microscopic amounts of this stuff deep inside particle accelerators like the ones at CERN. Second is storage. Because it annihilates the second it touches literally anything, it has to be suspended in a perfect vacuum using incredibly complex magnetic confinement fields. And third is safety and cost. It is extremely volatile, and producing just a single gram of antimatter today would cost trillions upon trillions of dollars. Fusion, the intermediate step. Because those engineering challenges are just so immense, we kind of have to be realistic about our immediate future. Harnessing fusion propulsion will very likely serve as the necessary practical bridge that we have to cross first. Fusion relies on combining atoms rather than annihilating them. And while it's still incredibly difficult, it's much closer to our current engineering grasp. And perfecting fusion will actually teach us the magnetic confinement and advanced materials science that we are absolutely going to need if we ever hope to handle antimatter safely. our next evolutionary step. If we zoom out from the particle accelerators for a second, the pursuit of antimatter is really about our grand cosmic destiny. As a species, we are fundamentally defined by the energy sources we learn to master. Think about it. In prehistory, our ancient ancestors mastered fire, which completely transformed human survival. In antiquity, agriculture transformed civilization. In the 18th century, industry transformed economies. And in the 20th century, computers transformed knowledge. Mastering space, potentially with antimatter acting as our ultimate new fire, is simply the next logical evolutionary stage for us. Which brings us to the close of our explainer today. We've seen the unbelievable, almost magical promise of E equals mc squared, and we've faced the sobering engineering realities of production, storage, and cost. But whether antimatter takes us there directly or fusion acts as the bridge we need, our trajectory is really clear. I want to leave you with this final, provocative thought to ponder today. Every generation is shaped by the technology it masters. The next chapter of human evolution may not be written on Earth, but among the stars. So, what technology will you help master to write that next chapter? Thanks for exploring this fascinating topic with me. Keep learning and keep looking up.